Protractor postulate is like the ruler postulate for segments. With segments you can measure the segment in a one-to-one correspondent with numbers basically on a ruler. And here we have, if you have an angle, you can find the measure between 0 and 180. Basically what these say is that angles can be measured. And that it'll be between 0 to 180. Okay. The angle addition postulate, let's see if I have angles 1 and 2, and this is A, B, and C. The angle addition postulate tells me that this point D is in the interior of angle ABC if and only if the measure of angle ABD plus the measure of angle DBC is equal to the measure of angle ABC. So essentially what this tells me is that the measure of angle 1 plus the measure of angle 2 is equal to the measure of the whole thing. So 1 plus 2 equals the whole. Using the angle addition postulate, we get that the measure of angle, find the measure of angle 1, so this is the one we're trying to find. If the measure of angle 2 is 56, and JKL, so this entire thing, is 145. So we can call this X, and you can use algebra to solve it. Or you don't have to call it X, and you can just use regular arithmetic and say 145 minus 56. Either way, you'll be doing the same math. It's just, would you prefer to set it up algebraically, or would you prefer to set it up as just a subtraction problem? Nine, 13 minus 5 is 8. So the missing angle is 89 degrees. Okay. We have the measure of angle 1 to be 23, and the whole angle ABC is 131. We need to find angle 3. What do we know about angle 2?
It's
90 degrees. So again, we can set that up two ways. We can set it up algebraically. If I call 3, say x, I can say 23 plus 90 plus x is equal to 131. Or I can do 131 minus 90 minus 23. And in either case, so I'd get either case, I'm going to get x is 18, or the measure of angle 3 is 18, so 18 degrees. Okay, so we have, if two angles form a linear pair, then they are supplementary, which means that the measure of angle 1 and the measure of angle 2 will equal 180. We already knew the definition of linear pair. We already knew the definition of supplementary. Now it's just a formal theorem. We also have the complement theorem. Basically what this says is if you have the non-common sides of two adjacent angles, these are the non-common sides. If those two sides form a right angle, then the two angles are complementary. So the measure of angle 1 plus the measure of angle 2 will equal 90 degrees. Again, we already knew this, but now it's a formal theorem. Using a transit, that's the thing on the tripod that they look through. Okay. A surveyor sights the top of a hill and records an angle of about 73 degrees. What is the measure of the angle the top of the hill makes with the horizon? So we have a guy with a transit, right? And he's looking through it, and he's looking at a hill. Okay. And
you're missing the width, right?
You're
missing the width.
I haven't finished labeling it, but hills should be green, don't you think? Nice, pretty green hill. Okay, so he's measuring this transit, and he goes from here. I can draw this. I can't draw. Hold on. Now I can draw. He measures that angle. Okay, so he's measuring the angle to the top of the hill from his transit. And he measures that at 73 degrees. Now the angle that he's measuring is this angle right here. When you measure, you're not measuring the angle down or up, you're measuring the angle down when you do that. That's why I wanted to draw the picture for you guys.
I thought the line was 73.
No, the angle is 73 degrees that he's getting from the transit, and that's from a line going straight up and down. Okay, so this angle is 73. I obviously didn't draw it correctly. And then if I draw a horizon line, again, this is not a very good picture, but so let's say this is the horizon. It's parallel to the ground. The angle that it's going to make between the horizon and the line that the measurement is based off of, this is going to be 90 degrees. Okay. So the whole thing is 90. He's measured 73, and we want to know what is this angle here, the angle that the top of the hill makes to the horizon. So basically the angle of ascent. That's what we're looking for. Well, if the whole thing's 90, what do I have to subtract? And that will give me 17 degrees. So when you're doing surveying, problems like this where 6 and 7 form a linear pair, if the measure of angle 6 is 3x plus 32, and the measure of angle 7 is 5x plus 12, I want to find angle x. So I'm trying to find x. I'm trying to find the measure of angle 6 and the measure of angle 7. So this is a three-part problem. Okay, so what do I know about linear pairs?
They're on the same line.
They equal something.
They equal. Linear pairs always equal 180?
Yep, linear pairs will always equal 180. So I can add those two together and it'll equal 180.
How do you know they equal 180?
Which line are we looking at? Our supplement theorem says if you have a linear pair, they're supplementary, which means they equal 180. So a straight line is 180. So if you're a linear pair, you make a straight line, it's 180. So 3x and 5x is 8x, 32 and 12 is 44.
So, okay.
Right, so 8x. Okay. I'm going to subtract 44. $136. And I'm going to divide by 8. And x is 17. So that's the first part. But I also want to find angle 6 and angle 7. Yes.
So when you set it equal to 180, what you were looking for was you're looking for that line, not the wall, right? Set it equal to that line.
Yeah,
Okay.
yeah. Whenever you're told, the only way to solve this is to know
that
what the total is.
Yeah,
this whole total, and that whole total is 180.
Okay, just make sure.
Yeah, and then if it was something like this and it was 90 degree, then the total would be 90. Okay. So in this case, though, we had the 180. So we found x. Now we need to find angle 6. So in order to do that, we plug in 17. And I get 51 plus 32, and that's 83. And then I can plug in 17 over here. And I get 85 plus 12, which is 97. And then a quick check. '83 plus 97 equals 180. So you got it, right? Our reflexive property of congruence for angles is the same as congruence for segments, which is the same as reflexive for equality. They look the same on both sides. Angle 1 is the same as angle 1. Symmetric, if angle 1 is the same as angle 2, then angle 2, is the same as angle 1. Don't know what I did there. So I can flip it around, the congruent, just like I can an equal sign. And then transitive tells me if 1 is the same as 2 and 2 is the same as 3, then 1 is the same as 3. And again, with transitive, you know it's transitive because you have the 2 and 2. And you just take that part out of the middle and put the ends together. Okay. Prove the transitive property is essentially what I'm going to prove here. So I've given that angle 1 and angle 2 are supplementary. So okay, I'm just going to abbreviate. And I'm given that angle 2 and angle 3 are supplementary. So I've been given both of those. Given. Okay. Now, what does it mean for them to be supplementary? Yeah, they equal 180. So that's, I'm going to define what those two things mean. So for both of those statements, it's the definition of supplementary. Okay. Now, I'm trying to get angle 1 equal to angle 2. I have angle 1 plus angle 2 is 180. And I have angle 2 plus angle 3 is 180. So I need to figure out a way to make
symmetric property? So transit.
I typed this wrong. Sorry, that's supposed to be 3. Yeah. Okay.
Transit, right?
I can use well, what I can do first is if I subtract 2 from both sides on both of these, won't they look the same on that other equal sign? Yeah, so if I say angle 1 is equal to 180 minus angle 2, and angle 3 is equal to 180 minus angle 2, I just subtracted. But now, don't they look the same? And if they're equal to the same thing, then they're equal to each other. And that you could put as substitution, or you could say transitive. And if they're equal, they're congruent. The congruent supplements theorem tells you that angles that are supplementary to the same angle are congruent. And that's telling me that if angle 1 and angle 2 is equal to 180, and angle 3 and angle 2 are equal to 180, then angle 1 and angle 3 are congruent. So any two angles add up to 180 if two different angles can add up to the same angle. So if I have like angle 1, angle 2, and angle 3, if 1 plus 2 is 180 and 3 plus 2 is 180, then 1 and 3 would be the same. Make sense, I think? And then you have the congruent complements. And we'll stop there. Okay, the congruent complements theorem tells us that if you have two angles and they're complementary to the same angle, so same idea, except instead of 1 and 2 adding up to 80, you have 1 and 2 adding up to 90, and 3 and 2 add up to 90, and then that would make angle 1 congruent to angle 3. Okay, so if you have same idea, two angles add up to the same angle to equal 90 each, then those two angles are the same. Okay, and we're going to